Yep.
G'day everyone, how are you going? Just a little lesson here on probability rules. We've been working on probability lately. These are really important to understand. If you don't understand them, when the tricky questions come in, you just kind of fall apart. The number questions are fine, but this is where the tricky stuff, really important stuff here. So the first one is probably the simplest one, and we're talking about complementary events. Now, just a bit of English here. E, complementary, comes from the word to complete. So finishing up the whole thing. The other one you're thinking about is if that was an I. That's complementary, like how you going? You're looking really good today. That's the complementary with an I. Okay, this one's the one with the E. So we're talking about completing something, finishing it up, not complementing someone. So probability of A prime or A dash, or you can write it with a line over the top, means everything outside of A. We don't want A. Nothing in A do we want. Now, think about a diagram here. If this is A, which clearly it is by the way I've done it, then everything outside of A is all of this and all of this. Well, remember probability on a Venn diagram, this whole thing is 1. Probability always adds up to 1. This whole thing is 1. So if we go 1 minus A, that leaves us with everything outside of A. So that's what we're doing here. The probability of A prime, A dash, outside of A is 1 minus everything inside of A. Okay? If I'm in a class and I've got boys and girls in the class and I say, well, I want everyone that's not a boy, that's all the girls, isn't it? If I want everyone that's not a girl, that's all the boys. If I want everything that's not A, that's everything outside of A. These spots here. Easy, moving on. Conditional probability. So this is where I might walk into a room and say, I need to choose a student at random, but they must be taller than this. I don't know, maybe I need them to carry something, lift something up, whatever, right? So therefore, if you're shorter than this, then you're not in the game. I'm sorry, you're not going to be chosen. So I'm reducing down the field of people I'm choosing from. Let's talk about this language here. This is B given, the line there, B given A. So A is the condition that I'm putting on it. A is the thing that I'm reducing it down to just a smaller number of people. Okay? So, let's have a look over here. So if I have the probability of B given A means I'm only looking in A. If it's outside of A, I don't care about it. So therefore, what I'm doing is, I'm only looking in this area here. So this is out, and of course because that's out, everything around here is out. Don't care about it, don't want it. So I'm only looking from within A. And then, from within A, I'm saying what's the chance that they're also in B? This area here. So this area here, this bit in the middle, that is the probability of A intersection B, isn't it? It's the bit in the middle. So I'm saying reduce it down to just A. Just A. And then tell me, from here, which ones also fit in B. Okay? So that's how we get that one. Okay? We're reducing it down to just in A. And from A, which ones also fit into B. So it's whatever this number would be, divided by all of A. Okay? So that's that one for us. Both important ones. This one especially so, because now we're going to use that one. What we're going to do is rearrange. Okay, I'll keep it on screen there. We're going to rearrange this. So can you see if I was to multiply this side by the probability of A, and multiply this side by the probability of A, these would cancel. And now I would have an expression for A intersection B in a different sort of way. Okay, A intersection B in a different way. Here it is. Probability of A times the probability of B given A. So this is just a rearrangement of my conditional probability. Now why is that handy? Why do I want that? Well, look here. Let's talk about independent events. If something is independent, that means that it has no effect on the other one. Okay? You know my example of saying, oh, I want someone this tall. Okay? If I walked into a basketball camp, right, basketball is generally a tall fellows and ladies, So if I walked into a basketball camp and I said, I need someone that's taller than this, but they were all taller than that, then it has no effect, does it? So independence, right? One doesn't affect the other if this here, B given A, if the A part of it actually doesn't change the probability at all, then B given A is just the probability of B. If A doesn't make any change to it, B given A is just the probability of B. Now you think, okay, well, I can kind of get that, but why do I care? Well, if we want to test for independent events, and somewhere in our question we can get those three pieces of information, then we just multiply these two, and if they answer this, that means they're independent. Because what it's telling me is effectively whether I put that there or I put probability of B given A, it doesn't make any difference. So because it doesn't make any difference, that's saying that actually B and A, they're independent. One doesn't affect the other. They're completely separate things. Okay? So the rearrangement of this is about putting it in a format where I can just use that equation, and if I can show that the right-hand side and the left-hand side are equal for a particular question, then I've proven that those events are independent. All right, so in a question, given the following information, determine whether A and B are independent, put them in, multiply. If this is correct, they are independent. If that's incorrect, then that means that this part, the given A, has some effect on the chance of B coming up, and therefore they're not independent. Okay? Hopefully that makes sense. If it doesn't, just remember this formula and go, okay, when I see independent, I've got to make that work. If it does, independent. If it doesn't, not independent. You won't be asked any more than that, just to show formula, use it. Right, next one. A or B. A or B. Very important wording. Or B. Have a read of it while I'm rubbing this off. A or B. So what are we doing here? To determine the probability A or B, we add the probabilities, but we make the necessary subtraction to compensate for the double counting. Alright? Let me draw up a sketch here. If I've got A and B, and I say all of A, well, all of A would be all of that, wouldn't it? And then all of B would be all of that. Can you see how I double counted the middle part? And remember that middle part is A intersection B, isn't it? So I've got to take away one lot of A intersection B. Okay, that makes sense? One or the other. Don't mind counting this bit in the middle once, because that's fine, but I don't want to double count it. So I take away one lot of it. Now from this rule then, we can use this about our mutually exclusive. What is mutually exclusive? It means they're completely separate. It means there's no overlap at all. They are completely separate things. So in this is not mutually exclusive, this diagram I've given, because there's an overlap. But if I had this here, here's A, here's B. They are mutually exclusive because there is no overlap between the two. There's no overlap in the middle. So if there's no overlap, then this is equal to 0. Because A intersection B, there would be 0. There would be 0. Yeah.
Then what is the difference between the mutually exclusive and the independent?
Right, I'll come back to that. Hold one sec. So this part, if that is equal to 0, we're in this situation, no overlap. So therefore what I can use is this formula here to prove mutually exclusive. So if that works, that means that there is no overlap, meaning they're mutually exclusive. Okay? Now the difference is, this is mutually exclusive, there is no overlap. Independence means that one doesn't affect the probability of the other. Alright? We'll come back, we'll do a couple of questions and you'll see when you get numbers and whatever to see the difference. This is that there is no overlap. The other one is one not affecting the other. There might be overlap, but it doesn't affect. okay, based on the numbers and the like. We'll come back to that. Last one down here. So the next bit down here is really just a bit of a sum up of what we've kind of already done for independence. Now, this first table, if A and B are independent, then B given A, independent. Well, that means the given part, the A part, doesn't make any difference. The B given A, well, if they're independent, A has no effect. So it's just probability of B. In a similar way, if these are independent, if A and B are independent here, then B has no effect on the chance of A being chosen. So just this. That one there was the one that we did up above, wasn't it? Okay, that was the rearrangement of one of these, and then understanding the cancelling part. Let me just flick back up. That one is this one right here, which remember was the rearrangement of this, and then making an adjustment around this to just be probability of B.
If it was like the probability of B given A, and
Yes.
they were mutually exclusive, would it just be 0?
Yes, it would.
Okay.
Yeah, correct. So the question was, if it was probability of B given A and they were mutually exclusive, as soon as you say given A, you're only looking in, I've got it there, only looking in that circle of A, well B never occurs in there, does it?
Yeah.
So you're right, it would be 0. Yes. So these ones here are true if they're independent events. So therefore, if we want to test for independence, well then we've got to show that these are true. Now notice it says either one of them. So if you can show one of those are true, then those events are independent events. Okay? And remember, the test for mutually exclusive, you're really going to be showing this is true. Essentially, you're showing there's no overlap. So quite important, these rules to understand, and whenever it asks you to show mutually exclusive, independent, etc., you've got to bring it back to the rules. You've got to use the rules. I'm pretty sure they're on our formula sheet. If they're not, put them on your page of notes that you bring in so that you can quickly refer to them and go, right, I've got to show that, get the numbers, show it works, and we're good. Any questions there?
Will this be on the same time?
This I can put, this is straight out of book.
Yeah.
This is cut pasted out of
this is
book.
on this book?
Yep,
Oh,
yep,
okay.
that's it, yep. But the video will be up there in a minute. Sorry everyone else, enjoy your day, see you later.